Hi, in this video I will explain the rules for naming cycloalkenes. Cycloalkenes are cyclic unsaturated hydrocarbons with a carbon-carbon double bond inside a cycle. These are examples of cycloalkenes like cyclopropene, cyclobutene, cyclopentane, and cyclohexene. How do we name cycloalkenes? In cycloalkenes, the main chain or the parent chain is the cycle, and that's why there is no need to find the longest chain, including the carbon-carbon double bond, and it is usually named by adding the prefix cyclo to the name of the alkene chain. The second thing, which is regarding numbering, is that in cycloalkenes, the double bond is always at position number 1. That's why there is no need to say, let's say, 1 cyclopentene, because it is always at position number 1. And always just make sure that the double bonded carbons are always 1 and 2, as we will see later on in naming. So if you assume that this is carbon number 1, then this should be number 2. And if you assume this is going to be number 1, then this should be 2. So you cannot say that this is carbon number 1 in the compound and then this is going to be number 2. It doesn't work in this way. So in cycloalkenes, the double bonded carbons are always at positions 1 and 2. And when numbering the branches must be assigned the smallest possible numbers with respect to their position to the double bond. And if alphabetical order is needed, then we have to take alphabetical order into consideration. Let's try to name some of the cycloalkenes. For example, here, so this is a cycle which consists of 6 carbons. That's why this is cyclohexene. As I said before, there is no need to put 1 cyclohexane because we already know that the double bond is at position 1. However, when I want to start counting the branches, if I have a branch at the double bond, then this branch will be definitely number 1. So this is going to be 1-methyl cyclohexene. In this second example, again, the main chain is a cyclohexene. And now I have a branch at this position here. So in this case, this is going to be position 1. So this is 1-isopropyl cyclohexene. This is a cyclopentene. Again, the branch is at the double bond, so this is going to be carbon number 1, and this is 1-ethyl cyclopentene. So if we just have one branch at the cycle and this branch is at the double bond, you just start numbering from that carbon. Now, what if we have more than one branch? For example, in this case here, both branches now are at the double bond. So I have two options. I can start numbering from this carbon here, which means that this is going to be number 1. So this carbon will be number 2. And the name will be 1-ethyl 2-methyl cyclohexene. Or I can start numbering from this carbon here, and the name will be 2-ethyl 1-methyl cyclohexene. Since we ended up with the same numbers, which are 1 and 2 in both cases, whenever you end up with the same numbers, then you have to use the alphabetical order rule, which states that the group which is written first according to alphabetical order should be given the smallest possible number. That's why this is an incorrect way for naming this compound, and this is the correct way for naming this compound. Because ethyl is written first, that's why it's given number 1, and methyl is written second, and it's given number 2. Let's take another example. Again, in this case here, we have two options. We can start numbering from this point, and my branches will be always at position 1 and 2. But I have two options, either to give the tertiary butyl group position 1 and the methyl position 2, or the methyl position 1 and tertiary butyl 2. Since tertiary butyl is written first according to alphabetical order, and remember, we are just looking at the letter B versus the letter M, then it should be given the smallest possible number, and that's why this is correct, this is incorrect. So whenever you have two branches at the double bond, then it's basically the alphabetical order rule which determines which way we are supposed to name or to number the compound. This solving strategy here can be used to name compounds other than those which have two substituents at the double bond. And it basically states use this mnemonic, which is start, drive, and stop. So always start at the branch double bonded carbon. So if you have a branch at the double bond, always start numbering from that branch. Drive means drive through the double bond. So when numbering, if you assign, let's say, this position 1, this means that you have to drive through the double bond and continue to the other side. You cannot just go the other way around. Okay, so you should always start from the branch at the double bond, drive through the double bond, and then continue your way into the other into the other branches, and then finally you stop at the last branch. Let's try to apply this method. For example, here I have a branch at the double bond and I have a branch outside the double bond. Definitely this is going to be position 1. If this is position 1, then definitely this is going to be 2 and this is going to be 3. So I started at the branch which is at the double bond, position 1. I drive through the double bond and then I stop here at position 3. So now my branches are at positions 1 and 3, and that's why the correct name for the compound is 1,3-dimethyl cyclohexene. Another example here. Now, this is a branch which is at the double bond, so this is going to be position 1. Now, someone might say, why don't you just go like 2 and 3? This is incorrect. Why? Because as I said, you have to start at the double bond, drive through the double bond, and then continue to your destination, which is this branch here. That's why this is going to be 1, 2, 3, and my branch is at position 4. In this case, in cycloalkenes, I don't care if I'm getting larger numbers because I have to apply the rule. So that's why this is the correct way for naming this compound. We have 4-ethyl, 1-methyl cyclopentene. More examples. Now, in this case here, there is no branch at the double bond. If there is no branch at the double bond, then you have to try 2 options and then see which one gives you a smaller set of numbers. For example, if I consider this carbon to be carbon number 1, and remember, the double bonded carbons should be always 1 and 2. So you cannot say that this branch, for example, is number 1. It's impossible. So if I assume that this is going to be carbon number 1, and I drive through the double bond, so through this carbon, the first branch will be at position 3 and the second branch will be at position 5. So now my groups or my branches are at positions 3 and 5. Now let's try the other way around, which is assuming that this is number 1, so this is number 2, which means that my first branch will be at 4 and my second branch will be at 6. So the branches will be at 4 and 6. Well, this one is the correct one because it gave us a smaller set of numbers. Let's try another example. Again, starting from here. This is 1, this is 2, so my branches are at 3, 4, and 6. So the first combination is 3 for the ethyl group, and then we have 4 for the methyl group, and we have a 6 for the methyl. This is incorrect, so this should be 6 here. So 4 and 6. The other option is start numbering from this carbon here. So this is 1, which means that this is going to be 3, this is 5, and this is 6. So I have the option of having 3, 5, 6. So 3, 5, 6 versus 3, 4, 6. Which one is a smaller set of numbers? This is a smaller set of numbers, 3, 4, and 6. That's why this is going to be the correct one. One more example. Now here, if I started counting at this carbon, this is going to be 1, 2, so the branches will be at 3, 4, 5, and 6, 3 and 6. And that's why we ended up with this one here, 3 and 6, this one. Or I can start counting from this carbon here, so this is 1, 2, my branch will be here at 3, and this one will be at 6. So in both cases, we ended up with this 3 and 6. In this case, whenever you end up with the same set of numbers, then you have to use alphabetical order rule, which is the group which is written first according to alphabetical order, which is ethyl should be given the smaller number. That's why this is going to be the correct way for naming this compound. Now we have another option here. So again, we have branches of the double bond and branches outside the double bond. So let's try both combinations. I have the option of starting from here. So this is 1, 2, 3, and 5. So my branches are at positions 1, 2, 3, and 5. If I move in the other way around, my branches will be at positions 1, 2, 4, and 6. So 1, 2, 4, and 6 versus 1, 2, 3, and 5. Which one is the correct one? It is the one which has the smaller set of numbers. That's why this is incorrect by the way. This is a correct way for naming it. So it's 1, 2, 3, and 5 is correct than 1, 2, 4, and 6. Okay, so this is correct and this is incorrect. So this is how we name alkenes using this method.